Hello everyone. In this video, we are going to see about the basic classification on number system, then little detail about rational and irrational number. And the next one, we are going to see how this decimal expansion is deciding the classification of real numbers. And then we will see operations on real numbers. First, we'll see the number system classification. So, number system can be classified into a real number and imaginary number. This imaginary number is going to deal with a complex number system, which we will discuss in our higher grades. And real numbers has been classified into two different types. One is rational and another one is irrational. We are going to see little detail about these rational and irrational numbers. So what are rational numbers? In this number line, I have specified from minus infinity to plus infinity. Among these, 1 to infinity is known as natural number, which has been specified using the letter capital N. Along with natural number, if we add 0, then they are known as whole number, specified using W. Along with whole number, if we add the negative number, then we can say they are known as integers using the letter Z. Now see, in between the whole number, we may have some ratio of numbers also. Here between 1 by 2, I have 3 between 1 and 2 I have 3 by 2, between 2 and 3 I have 5 by 2, between 3 and 4 we have 7 by 2. So all these are ratios of whole numbers, so all these known as fractions. Same, we have the ratio of integers also, so that has been specified over here. On our negative side also we have the ratio, but they are not whole number ratios, they are having the ratio of integers. So minus 7 by 2, minus 5 by 2, minus 3 by 2. So these ratios are known as rational numbers, but these rational numbers can also include the fractions. So all fractions are rational number, but all rational numbers are not fractions. The next thing is, what are irrational numbers? So what are irrational number? They are also come under real number category only, but they cannot be written as a simple fraction. And the radicals of natural numbers are irrational. When I can say the radical as irrational, if I cannot find any value for the radical, then we can say they are known as irrational number. Some example is root 2 and pi. We have so many example. Here I have specified just root 2 and pi, because this root 2 and pi cannot be written as a simple fraction or a ratio of integers. And this 22 by 7, actually we all know what is pi value. So usually in circles and all, we will be substituting the pi value as 22 by 7. But this 22 by 7 is a rational number and pi is an irrational number. Then how can these two will be equal? Because this 22 by 7 is not an accurate value of pi, it's just an approximate value of pi only. They both are not equal, but we are taking the approximate value of pi as 22 by 7 for calculations. The next one is real numbers with decimal expansion. So maybe here I have specified the ratio of integers. So I'm going to find what is the decimal expansion of this ratio using the long division method. So we will divide, right? So why I'm going to divide using x. So in this long division, if I get the decimal expansion as a terminating one, then we can clearly say that is the given ratio is a rational number. Maybe if it is not terminating, it's come under the category of non-terminating, then it may falls under these two category. So the decimal expansion what we are getting, it may be a repeating decimal or a recurring decimal, or it may be a non-recurring or non-repeating decimal. If it is a repeating decimal, then we can say that's a rational number. If it is a non-repeating decimal, we can say it's an irrational number. So here I have given an example 1 by 4 and 1 by 3. Just we will find what it is. So I am going to divide 1 with a 4. So it's a long division method. So 1 cannot be divided by 4. So we are going to add 0 and including a decimal point. So 4 twos are 8. So again 2, 0. Now 5. So what is actually 1 by 4? 1 by 4 we are getting as 0.25. So what is the meaning of this? It's a terminating decimal. So it will come over here. So 1 by 4 is a rational number. We can fix it. Now 1 by 3 we need to check. So what is 1 by 3? We'll check it. So we are going to divide 1 by 3. So 1 is smaller than 3. So what we are going to put? 0 by putting one decimal point. So 3 3s are 9. So I'm putting over here again balance 0, again putting 0, 3, 3, 9. So again we are getting 1. So it is going to repeat like this till infinity, right? So we will be getting 3, 3, 3 continuously. So what category is this? It's a non-terminating decimal. So this category it falls, and it's actually a recurring one. The decimals are repeating. So what is that? 0.333. It's repeating. So even I can write this in this manner, where whenever the digits are repeating, we can specify using the bar. So these are the another way to represent this 0.333. So this is known as a rational number. Why? Because it is non-terminating and recurring too. This is how we can classify the real number using the decimal. Then the next thing is operation on real numbers. If we add, subtract, multiply or divide, as there are four basic operation, if we are using four basic operation between two rational number, then we will get the result also as rational number only. And the sum or difference of rational and irrational number, maybe we are using one number as rational, another number as irrational, sure we will get the result as an irrational in sum and difference. And the product or quotient of non-zero rational number and another one as an irrational number, sure here also we'll get the result as an irrational number. Now we are going to use the basic operation addition, subtraction, multiplication and division between two irrationals. That means both the number are going to be an irrational number. Then our result may be rational or an irrational. We cannot fix it will be rational only, irrational only. According to the problem, it will get vary. Now we'll see some examples on operations of real numbers. See the first question, 2 minus root 3. So what is 2 actually? It's a rational number. So actually rational number can be specified using Q, and irrational number can be specified using the letter Q bar. So 2 is a rational number and root 3 is an irrational number. So an subtraction operation between a rational and irrational will always give us irrational number. And see here, this is an irrational number, q bar minus q bar. Both are irrational. So if we are using the subtraction on both irrational number, then the result may be rational or irrational. So we'll check what is the result first. So it's going to be 3 plus root 23 minus root 23. See here, plus root 23 and minus root 23 got cancelled. So I got the result as 3. It's nothing but the rational number. And here 2 root 7 and 7 root 7 both are irrational number only. So root 7 can get cancelled. So we will be getting the answer as 2 by 7, which is a rational number. And see here 1 by root 2. So 1 is a rational number, root 2 is an irrational number. So a division operation between a rational and an irrational will give you always irrational only. And see here 2 is a rational number, pi is an irrational number. So if we multiply one rational with irrational, we'll always get an irrational number as an answer. Now in video 2, we are going to see what are surds or radicals, what is rationalizing factor, how to do the rationalization of surd along with some example problems. Thank you.